Good day everyone. Today I'm going to discuss the area and distance in Calculus 2. This topic is one of the most important application of integration because it helps us measure regions, movements, and total change. It is widely used in engineering, physics, architecture, economics, and many real-life situations. To begin, I am Sharon J.C. Solon. Let us first understand the idea behind the area and distance in Calculus 2. These concepts are mainly solved using definite integrals. Integrations allows us to find the exact value of quantities that are continuously changing. For area, it measures the space enclosed by curve. For distance, it helps us calculate the total length traveled by an object based on its velocity. This is why integration is very powerful in solving the real-life problem. How do we define area between curves? First, two non-intersecting functions with arbitrary boundaries. Second, two functions that have two or more points of intersection. Third, triangular regions bounded by three functions. Area of a region. So for area of a region, we have three. So first is the area of a region between f and j. So integration a from b, f of x minus g of x dx. Second, area of region under f of x. So integration a from b, f of x dx. And the third one, area of region under g of x. Integration a from b, g of x dx. And now let's proceed to area of a region between two curves. If f and g are continuous on a and b, and g of x is less than equal to f of x of all x in a and b, then the area of the region bounded by the graphs of f and x and the vertical lines x is equal to a and x is equal to b is area equals integration a from b, f of x minus g of x dx. Proof: find the limit of the area of rectangles given by a representative rectangles. Here is the illustration. The area will be the limit of the sum of the areas of infinite representative rectangles with infinitely small intervals as n approaches to infinity. So the limit as n approaches infinity of the summation from I equals to 1 to n of f of x summation of I minus g of x summation of I times delta x. So this is the interval integration of a from b, f of x minus g of x dx. So here's are the step, hints, and tricks. So first, if not given, find the points of intersection by setting equations equal to each other. These are your interval values from a and b. Second, graph may intersect in more than 2 points. Find all and apply. Third, if a graph is a function of y, then change your perspective horizontally. A and B would be your y values. Then the fourth one, if the graph switch relatively position, top and bottom, or left and right, then you must break the integral into separate integrals. See above the graph. So see the illustration.
So find the area between the two curves. 2x squared plus 4x plus y is equals to 0 and y is equals to 2x. So first step, we have to find the intersection. So we have 2x less than equal to negative 2x squared minus 4x become 2x squared plus 6x equals to 0. So then it becomes 2x times x plus 3 is equals to 0. So we have x is equals to 0 and x is equals to negative 3. So the limit are from negative 3, x is equals to negative 3 to x is equals to 0. And now we have to find for y is equals to 2x. So y is equals to 2, so negative 1 for x, and it becomes negative 2. So for y is equals to negative 2x squared minus 4x. So we have y is equal to negative 2, change the x to 1, plus 4 is equals to 2. So for the area formula, so for the upper curve, we have y equals negative 2x squared minus 4x, and for our lower curve, we have y is equals to 2x. So let's proceed to the area formula. So for the upper curve, we have y equals negative 2x squared minus 4x, and for our lower curve, we have y is equals to 2x. So let's proceed to the area formula. Area formula, we have a equals integration from negative 3 to 0, negative 2x squared minus 4x minus 2x dx. A is equals to from integration of negative 3 0, negative 2x squared minus 6x dx. Area formula, we have a equals integration. So we have to integrate the negative 2x squared minus 6x. So integration of negative 2x squared dx is equals to 2x cubed all over 3. And the integration of negative 6x dx is equals to negative 3x squared. So now we have to input the negative 2x cubed all over 3 minus 3x squared. Integration from negative 3 to 0. And now we have to input the x and change it to 0. It equals to 0. So now let's move to negative 3. So we input 2 negative 3 cubed all over 3 minus 3 times negative 3 squared. So we have negative 2 times negative 27 all over 3 minus 3 times 9. So we have 118 minus 27, then negative 9. So we have negative 9. So a is equals to 0 minus negative 9. So our area is equals to 9. So we have to integrate the negative 2x squared minus 6x. So integration of negative 2x squared dx is equals to 2x cubed all over 3. And the integration of negative 6x dx is equals to negative 3x squared. So now we have to input the negative 2x. For our first table, we have y is equal to 2x. For our second table, we have y is equal to negative 2x squared minus 4x. First table, we have x and y. Second, x and y. Then for our x, we have negative 3, negative 2, negative 1, 0. For y, negative 6, negative 4, negative 2, and 0. Our second table, we have for x, negative 3, negative 2, negative 1, and 0. And for our y, negative 6, 0, 2, and 0. Since we're done to our table of values, we can easily do our graph. First, we have to plot each points. Then, those points, we have to connect them. Now, we carefully plot the points and connect those points. And now, we have our first curve. Then, let's proceed to our second curve. Now, we do the plotting of the points. Then, after that, we have to connect them to form the second curve. Now we have our second curve. Let's proceed to our conclusion. Therefore, the area of the region is 9 square units. Since we're done, so find the area between the two curves. Our equations are from y squared is equals to 2x plus 3. So it becomes x is equals to y squared minus 3 all over 2 for curve 1. From y equals to x, so x is equals to y for curve 2. So find the intersection point. You have to set the equal. Y is equals to y squared minus 3 all over 2. We have to multiply 2y is equals to y squared minus 3 and then rearrange. Y squared minus 2y minus 3 is equals to 0. And now let's factor y minus 3. Y plus 1 is equals to 0. So we have y is equals to 3 and negative 1. So we have to set up our integrals within respect to y. Right to left, so x is equals to y minus y squared minus 3 all over 2. A area is equals to integration from negative 1 to 3. Y minus y squared minus 3 all over 2 dy. We have to simplify the integral equals to integration from negative 1 to 3, negative y squared plus 2y plus 3 all over 2 dy. So now let's integrate. Was 1/2 integration of negative y squared plus 2y plus 3 dy, and then 1/2 minus y cubed all over 3 plus y squared minus plus 3y. So we have to evaluate the limit, plug in the 3 and negative 1. So we have our final answer. A is equals to 16 all over 3. For our table of values, we have first table y is equal to x, and our second table x is equal to y squared minus 3 all over 2. So our first table of x and y. Then for our first table, we have our x, negative 1, 0, 1, 2, and 3. For our y, negative 1, 0, 1, 2, and 3. For the second table, we have for x, negative 1, negative 1, negative 1.5, 0, negative 1, 1, 0.5, 2, 3, and 3. Since we're already done to our table of values, we can now do our graphing. With the help of the table of values, we can easily use it to plot the points, then connect that point and become a curve. So now let's plot the points for our first curve. So after plotting the points, we can slowly connect those points to form a curve, or what you call this, a line. And now we have our first curve. Let's proceed to our next curve. First, we have to again plot the points, every points with the help of our table of values. And that points will be our guide to do our next curve by connecting those points. And now we're done to our second curve. Let's proceed to our conclusion. Therefore, the area of the region is 16 over 3 square units. Since we're already done to our table of values, we can now do our graphing. With the help of the table of values, we can easily use it to plot the points, then connect that point and become a curve. So now let's plot the points for our first curve. So after plotting the points, we can slowly connect those points to form a curve, or what you call this, a line. And now we find the area between the two curves. Our given equations are y squared is equals to 1 plus x and y is equals to 1 minus x. So for step 2, we have to express in terms of y. So we have y squared is equals to 1 plus x. Y squared is equals to 1 minus x. So for our curve 1, we have x is equals to y squared minus 1. For curve 2, we have x equals 1 minus y. So we have to find the intersection. So y squared minus y is equals to 1 minus y. So next is to simplify the equation. Become y squared plus y minus 2 equals 0. So y plus 2 y minus 1 is equals to 0. So solve for bounds, we have negative 2 and 1. So identify the left and the right curves. So now let's set up the area formula. We have area is equals to integration from negative 2 to 1 minus y minus y squared minus 1 dy. So let's simplify the integral. We have 1 minus y equals 2 minus y minus y squared. So we have 2 integration of 2 minus y squared dy. So now we have 2y minus y squared over 2 minus y cubed all over 3. So we have now our final answer 9 over 2. For table of values, we have for first table x is equal to y squared minus 1. For second table, we have x equals to y minus 1, x and y, x and y. For our first table, x equals to 3, 0, negative 1, 0. For y, negative 2, negative 1, 0, and 1. For our second table, we have for x 3, 2, 1, 0. And for our y, negative 2, negative 1, 0, and 1. And now, let's go to graphing. With the help of our table of values, we can easily locate those points, and with that, we can easily connect those points in forming our curves. So here, as you can see, we slowly doing our curves. And now, let's go to graphing. With the help of our table of values, we can easily locate those points, and with that, we can easily connect those points in forming our curves. So here, as you can see, we slowly doing our curves. And now, let's go to graphing. With the help of our table of values, we can easily locate those points, and with that, we can easily connect those points in forming our curves. So here, as you can see, we slowly doing our curves. And now, let's go to graphing. With the help of our table of values, we can easily locate those points, and with that, we can easily connect those points in form. Since we're done doing our first curve, now let's proceed to our next curve. So before that, we have to again plot the points and connect those points. So we slowly do it. So we're done with our second curve. Now let's proceed to our conclusion. Therefore, the area of the region is 9/2 square units. Find the area between the two curves. Our given equation is y is equals to x squared, x minus 3, and y is equals to x squared. So step 1, find the points of intersection. Y is equals to x squared, x minus 3. So y is equals to x squared. So x squared, x minus 3 is equals to x squared. So now let's simplify the equation. X cubed minus 3x squared is equals to x squared. And now it becomes x cubed minus 4x squared is equals to 0. So now we have x squared, x minus 4 is equals to 0. So step 4, we have solve for bound. We have x is 0 and 4. We have to identify the upper and the lower curve. Upper is y is equal to x squared, and the lower is y is equal to x squared, x minus 3. And now let's set up the area formula. Area is equals to integration from 0 to 4, x squared minus x squared, x minus 3 dx. So we have to simplify the integral. Now we have x squared minus x cubed minus 3x squared is equals negative x cubed plus 4x squared. So now we have to integrate. Integration of 4x squared dx is equals to 4x cubed all over 3, and the integration of x cubed dx is equals to x to the power 4 over 4. So now let's have to evaluate the definite integral. We have a is equals to 4x cubed over 3 minus x to the power 4 over 4. And now our final answer is, find that we will do 56 over 3 minus 64. And now for our final answer, we have area equals 64 over 3. Find the area between the two curves. For our table of values, we have first table y is equal to x squared, second table y is equal to x squared, x minus 3, x and y. So first table for x, we have 0, 1, 2, 3, and 4. For y, we have 0, 1, 4, 9, and 16. For our second table, we have for x 0, 1, 2, 3, 4. And for our y, 0, negative 2, negative 4, 0, and 16. And then again, since we're done with our table of values, we can now proceed to graphing. With the help of our table of values earlier, we can easily locate or plot the points, and with that point, we can form a curve. So, be slowly doing our curve. Our first curve. So we're done with our first curve. Now let's proceed to our second curve. First, we plot the points again. Then we connect those points. And now we have our second curve. So let's proceed to the conclusion. Therefore, the area of the region is 69/3 square units. Then again, since we're done with our table of values, so find the area between the two curves. Our given equation is y is equal to x cubed plus 3x squared minus 4 and y is equal to 2x squared. For step 1, we have to find the points of intersection. We have y is equal to x cubed plus 3x squared minus 4. So we have y is equal to 2x squared. So x cubed plus 3x squared minus 4 is equal to 2x squared. So let's have to simplify the equation. We have x cubed plus x squared minus 4 is equal to 0. So we have to determine the bound. And now let's go to set up the area formula. We have the upper curve versus the minus the lower curve. A is equal to integration of 2x squared minus x cubed plus 3x squared minus 4 dx. So let's simplify the integral. We have area equals my negative x cubed minus x squared plus 4, so dx. Now we have to integrate, and now we have the final answer 7/2. For a table of values, we have y is equal to x cubed plus 3x squared minus 4. Our second table, we have y equals to x squared, x and y. For our first table, for x, negative 2, negative 1, 0, 1, and 2. For y, 0, 0, negative 4, 0, and 16. For second table, for x, we have negative 2, negative 1, 0, 1, 2. For y, we have 8, 2, 0, 2, and 8. For a table of values, we have y is equal to. Since we're done doing our table of values, we can now proceed to graphing. With the help of our table of values, we can easily locate those points, and with the help of the points, we can connect those in forming a curve. So now, let's slowly do our curve, our first curve. So as you can see in the graph, we are carefully doing our curve. So we almost done with the first curve. So now let's proceed to our second curve. We have to again plot the points, and that points we connect those in forming a curve or forming our second curve. And now, we're almost done with our second curve. So, now let's proceed to our conclusion. So, for our conclusion, therefore, the area of the region is 7/2 square units. Since we're done doing our table,
I hope you learned something and thank you for watching.